Today, we are diving into one of the greatest stories in science. It's got a suspicious king, a brilliant inventor, and a single world-changing moment in a bathtub. This one discovery didn't just solve an ancient crime, it's the reason a 200,000-ton steel ship can float on water.
So that's the big question, right? It seems kind of impossible. A little steel nail sinks in a second, but a massive ship just floats. Well, the answer comes from a flash of genius that happened over 2,000 years ago. Let's get right into it.
Okay, so let's set the scene. We're in ancient Syracuse, and the ruler, King Hiron, has a problem. He'd commissioned this incredible, ornate crown, supposed to be made of pure gold. But when he got it, he had this nagging feeling, this suspicion that the goldsmith had ripped him off by mixing in cheaper silver and keeping some of the gold.
So the king goes to the smartest guy around, the famous inventor, Archimedes. And the challenge he gives him is honestly huge. He says, figure out if this crown is pure gold, but you can't damage it. He couldn't melt it, he couldn't even scratch it. I mean, how would you even begin to solve that?
So Archimedes is thinking about this impossible problem, just turning it over and over in his mind, and he decides to take a bath. As he gets into the tub, which is filled to the brim, he sees the water rise and spill over the side. And he notices that the more he sinks into the tub, the more water gets pushed out of the way. And bam! In that one moment, it all just clicked. He realized that the volume of water that spilled out was related to the volume of his own body. He had the solution. The story goes he was so unbelievably excited that he leaped out of the bath, ran into the streets, totally naked by the way, shouting, "Eureka! Eureka!" which in Greek just means, I have it. You see, that bathtub moment wasn't just a random idea. It was the key that unlocked a whole new set of scientific tools. So to really get how Archimedes cracked the case, we first need to understand the tools he suddenly had to work with. First thing in the toolkit, mass. This is just the amount of stuff something is made of. Think about it. A bowling ball has way more mass than a beach ball. And what's really important is that your mass is the same whether you're standing on Earth or floating on the moon.
Next up, we have volume. This one's easy. It's just how much space an object takes up. So that beach ball, even though it has very little mass, takes up a ton of space. It has a much bigger volume than the bowling ball. Now, density is the concept that ties it all together. It's the crucial link. It basically asks how much stuff is crammed into a certain amount of space. So a little piece of lead is super dense. A giant block of styrofoam, not dense at all. And here's a super handy little trick to remember how they all relate. With this triangle, you just cover up the thing you're trying to find. Want to find density? Cover it with your thumb, and you're left with mass over volume. It's a simple but really powerful little tool. Now, here's something people mix up all the time. Mass versus weight. They are not the same thing. Your mass is the stuff you're made of. It's constant. Your weight, though, is just the force of gravity pulling on that mass. It's why you'd be weightless in deep space, but you'd still have all your mass. Okay, the next tool in our kit is a big one, buoyant force. All this is the upward push that a fluid, like water, puts on anything that's in it. Think of it as a force that's always fighting against gravity. And you know this feeling, right? The second you jump in a pool, you suddenly feel lighter. You can lift people up you could never lift on land. Well, that's the buoyant force in action, giving you a helpful push upwards. And this, right here, is the absolute heart of it. This is the big idea Archimedes had in the tub. The upward push an object feels is exactly equal to the weight of the water it pushes out of the way. It's a perfect one-to-one relationship. All right, our toolkit is ready. We've got mass, volume, density, and buoyant force. So let's head back to the crime scene and see how Archimedes put all of this together to expose the cheating goldsmith.
The entire solution hinged on one simple fact: density. See, Archimedes knew that gold is an incredibly dense metal. It's way, way denser than silver. And that meant a crown made of pure gold would be less bulky, it would have a smaller volume, than a crown of the exact same weight that was mixed with silver.
So just imagine you have two crowns, and they weigh exactly the same on a scale. The one that's mixed with the less dense silver has to be physically bigger to make up that weight. And a bigger object, one with a larger volume, is always going to push more water out of the way when you submerge it. And the actual experiment?
So simple, but absolutely brilliant. First, Archimedes would take a lump of pure gold that weighed exactly the same as the crown, dunk it in water, and measure how much water it displaced. Then, he'd do the exact same thing with the king's crown, and if the crown pushed out more water, it meant it was bigger for the same weight. Proof: it wasn't pure gold. The goldsmith was caught red-handed.
But you know, the story is so much bigger than just one crooked goldsmith. This principle, discovered in a bathtub, literally keeps our modern world afloat. Let's see how it scales up from a crown to, well, everything. So when you put something in water, it really comes down to a battle between two forces. You've got the object's own weight pulling it down, and you've got the buoyant force from the water pushing it up. The winner of that tug of war decides if it floats or sinks.
It really is that simple. If the object's weight is more powerful than the upward push, it sinks. If the two forces are perfectly matched, it'll just kind of hover in the water. But if that buoyant force is stronger, the object gets pushed up until just enough of it is sticking out of the water to make the forces perfectly balanced. This all gets summed up in what's called the law of flotation. Basically, an object floats when it has pushed aside an amount of water that weighs exactly the same as the object itself. It just naturally finds its perfect balance point. And that brings us all the way back to our big puzzle. How does a giant steel ship float? The answer is shape and volume. A ship isn't a solid block of steel. It's mostly a hollow shell. Its curved hull traps a massive amount of air inside, which gives it an enormous volume. This means its overall density, the steel plus all that air, is actually way less than the density of water. It's able to displace enough water to float with ease. From massive container ships to submarines diving into the depths, even to hot air balloons floating in the sky, which is just a fluid after all. Archimedes' bathtub discovery is absolutely everywhere you look. It really makes you wonder, what simple, everyday puzzle is right in front of you, just waiting for its eureka moment?